Here's something to explain, just to illustrate just how crazy the circumference formula is. We've got the circumference is 2 pi r, or the circumference is pi times the diameter. Suppose the Earth is a perfect sphere, with no oceans or anything else, no mountains or whatever, and you run a length of rope tight around the Earth. Let's say we use a blue piece of string. Blue piece of string goes tight around the equator, and it's snug down. And then we add in just the tiniest little loop of slack into it, of exactly, let's say, a yard of slack into the rope. And then you have all these people try to lift up the rope all around the world at the same time. How high up would they be able to lift it? Now, everyone's instinct is, the Earth is so big, you add just a yard of slack in, you're not going to be able to lift it up all that much. But watch what happens. Let's use a side view. Side view. The radius of the Earth is some r sub e, radius of Earth. And so how much rope do you have? You have the circumference is 2 pi, well, let's just use r. 2 pi r is how much rope you have. And now we add a yard plus, let's say, 3 feet, which is a yard, and we get 2 pi r plus 3 feet. Let's C prime, the new circumference. What is the radius going to be? R prime. Well, how do we do this? This is, let's see, pi is approximately 3, roughly speaking. So this is 2 times 3 times r plus 3. We can factor out a 3 of this, and we'll get 3 times 2r plus 1. I'm doing a lousy job here. It's 3 times 2 times r plus a half, because 2 times r is 2r, 2 times a half is 1. And so if we can take this back to pi times, this is roughly pi times 2 times r plus a half, we get 2 pi r plus a half. The lesson is, the answer is 1/2 a foot up. Blows the mind, doesn't it? What I'm saying is, if you had a piece of string that went tightly around the Earth, and then you added in 3 feet of slack, you would be able to lift the rope away from the Earth 1/2 a foot all the way around. It's pretty amazing. This is how circumferences work. Let's do a couple more realistic examples. That is, stupid examples. You have a circle with a radius of 10 feet. The circumference is 2 pi times 10, which is 20 pi feet, which is approximately, we can use 20 times 3.14 feet, which is what? 62.8 feet. So if you have a 10-foot radius circle, it's approximately 62.8 feet around. I might give you something where I say it is 30 inches across. What is the circumference? It helps to say, well, if the diameter is 30 inches, then the radius is half of that, right? Diameter is 2 radius. That means that the radius is 1/2 the diameter. So the radius is 15 inches, and the circumference is exactly 2 times pi times 15. Well, why didn't we use the C equals pi d formula? Why not? But anyway, it's going to be 30 pi inches. That's another important detail I want you to know. If the radius is in feet, the circumference is in feet. If the radius is in miles, the circumference is in miles. Whatever length you're using to measure your diameter or your radius is the same measurement that your circumference is going to be in. That will pop up later. Let's end this.